Yeah, so you can use the kiss. So you can use
Okay, first and foremost, I think I want to go through your RX assignment. Can you all take out your green pen or pencil? Let's do correction together. Okay, MSA will return to you on Wednesday, 10th February during the lecture slot itself. Yeah, but I've already marked the papers for this class. The good news is 7 out of 10 scored 20 and above. The bad news is 3 didn't and 1 scored S. So you can see how big the disparity is in this class. Okay. Right now, I just want to put it very generally. For those who didn't do that well, you need to catch up with your peers. And after looking at the result for this MSA, it gives me a very ambitious dream, whereby maybe next year, 100% of this class can get A or A level. Amen. Then what, right? So for PT1, okay, PT1 let's aim for 100% pass. PT2, 100% AB. Prelim 100% A. Then A level, wow, that's nice. Then okay, without further ado, let's start with our discussion of the RX assignment. Let's start with question 1. Question 1, very simple. Describe the mechanism. So always remember, when you are asked to describe mechanism or outline mechanism, the first thing that you should do is, what's the first thing that you should do? Yes, Wei Name, yes, that's correct. So in this case, remember to name, and of course, before you even know what type of nucleophilic substitution it is, you look at the Rx given. If it is primary Rx, what type of nucleophilic substitution? SN2. If it's tertiary, SN1. Very good. So here we have primary Rx, therefore it is SN2. So this is how you present your answer. So always remember SN2, the characteristic feature is it is a backside attack. Therefore, the incoming nucleophile should come directly opposite to your leaving group. Directly opposite will be here. Okay, here, not here. And of course, remember to put your lone pair of electrons, your dipoles, and of course the heterolytic fission of the CCl bond, which some of you left out. Okay? After that, we move on to the transition state. Here, very important. Some of you, instead of putting C partially forming a bond with N, some of you put H3N. By putting it like this, you are telling me that a partial bond is formed between carbon and hydrogen, which is not the case. Okay, so please be very careful how you position your atoms. And of course, for your transition state, I need you to put square bracket. And in this case, because the incoming nucleophile is neutral, there is no charge on the transition state. Are we clear about this? Can I? Then put it down. Okay, now we come to the product. The product, make sure it is mirror image of your starting material, isn't it? And when I say mirror image, it means that it is a point-for-point reflection, which means here, CH3, right? Let's assume that there is a mirror in the transition state. So CH3 is near to the mirror. In the reflection, CH3 will also be here. The bond stays the same. Single line, single line. Here, dash, here, dash. Wedge, wedge. You understand? Point-for-point reflection. And then here, make sure it is NH2. Remember, it is always -1, and I don't want to see things like C, H, and H2N, no such thing. It is the N that forms a bond with the carbon. And for this special case, remember the side product is HX. If you are using OH minus, CN minus, it will then be X minus. Clear? Yeah. This part, I think I don't want to harp too much because I already said before, this is the template, the format of presentation. Here, very, very important, please do not reinvent the wheel. I remember very clearly in our format of presentation, the second point, extent of effective orbital overlap. Please do not tell me effective overlap. Overlap of what? Right? And please do not tell me orbital overlap. Where's the keyword effective? So don't reinvent the wheel. Remember that the three words, effective orbital overlap, cannot be separated. Okay? And of course, as far as possible, stick to the way I present it. Some of you like to say, the orbital overlap becomes less effective. What for? Just stick to what I gave you. Extent of effective orbital overlap becomes poorer or becomes better. Okay? Are we clear about this? Okay, so to prepare you for exams, remember every time you see the word explain, explain means to give details. So you shouldn't be stingy on your words. Make sure you give a complete picture. Okay, finish? Oh, yeah. How about Brenda is sitting at the back today? Would you like to be flanked by two hunks?
She like to be.
Or are you sure it's not sheep? Or are you sure it's not sheep? Huh? Your lingo, right? You're always sheep, right?
How to sheep people, yeah?
No, it's not. Oh my god.
See, I use the lingo, then you, huh? What on earth is Mr. Thing saying? What?
No Bella, it's actually the same.
Go Pasabella, sure Bella. Okay, finish?
Yeah.
Okay, this part over here, very important. It is careless mistake, especially for Q. A lot of you didn't realize that in P, there are altogether 4 carbons. 1, 2, 3, 4. So what happens is that for Q, some of you only show me 3 carbons. Don't. Remember, the C involved in the C triple bond N eventually will become COOH. Alright? Here for R, some of you do not know how to get the product. So let me show you how do you form the ester. In this case, we are using butane, is it butanoic acid? Yeah, butanoic acid. Okay, we are using butanoic acid, and then the alcohol is actually your ethanol. What is wrong with this? Anything wrong? What is wrong? Exactly. If you write like this, you are telling me that this carbon has 5 bonds. Where are the 5 bonds? CO, the 3 CH bond, and CC. Cannot be the case, right? So please, when you use structural, condensed structural formula, please bear in mind that condensed structural formula reflects how the atoms are bonded to each other. Okay? So it should be like this. Okay? So some of you do not know how to get the product after carboxylic acid and alcohol react together. By the way, what is the type of reaction for this? Is it esterification? Is it esterification? Yes. Yes. Type of reaction is esterification. Is it? Yes? No? Yes? No? No, okay. Type of reaction is not esterification. But rather it is condensation. Why is it condensation? Because you know that a small molecule is being removed, and this small molecule is water molecule. How is the water molecule obtained? Look very carefully at the whiteboard. I'm going to remove this and this. This will form the water molecule. So after that, the remaining parts will join up together. Form your ester. So this is the ester functional group. And okay, here, if you are asked to write the condensed structural formula, it will be like this: CH3, CH2, CH2, COO, CH2, CH3. Okay. Alternatively, sometimes you see that in textbook, it is like this: OCO. When you are given OCO, what it means is that this part belongs to the carboxylic acid, so it should be CH2, CH2, CH3. Then this part belongs to the ethanol. So in other words, there is a swapping of position. Okay, if you write COO, that means here will be from acid, here will be from alcohol. If you write OCO, here will be from alcohol, here will be from acid. If I write OOC, should be wrong. Why? OOC, the OO, are you telling me that there is a peroxide bond? So no OOC, either this or this. And are we okay? Okay, people, here I also want to introduce you another name for the type of reaction. Other than saying that this is condensation, it is actually nucleophilic substitution. Why is it nucleophilic substitution? Okay, why is it nucleophilic substitution? Because on this carbon itself, it has a delta positive. Why? It is bonded to two electronegative elements. And then on our O here, there are two lone pairs of electrons. So one of the lone pair of electrons can actually attack the delta positive carbon. But then here we have an issue, isn't it? Because here you notice that in order for it to be nucleophilic substitution, there must be a leaving group. Correct? But here, just to tell you, our OH does not like to leave as OH minus. No, it doesn't. Then how? So the thing is, that's why we have our best friend, your concentrated sulfuric acid, act as the catalyst. So how does the concentrated sulfuric acid act as the catalyst? Let me show you. Let me go into the mechanical details. So we know that in order for nucleophilic substitution to happen, there must be a leaving group. So instead of leaving as OH minus, which is unfavorable, in this case, this part over here is going to call H plus to come over. H plus from your concentrated sulfuric acid. And then here you know that there is also no pair of electrons. So what happens is that, okay, it is now going to be protonated to form an oxygen with 3 bonds. So previously we learned that nitrogen likes to form 3 bonds. The moment it forms 4 bonds, there is a plus charge. So for oxygen, it likes to form 2 bonds. The moment it forms 3 bonds, there is a plus charge. So once this is done, our alcohol, the lone pair of electrons on oxygen, can then attack the delta positive carbon, and this part will leave as H2O. And then you may ask me, yeah, now okay, there's a bond formed between O and C. What about this H? Right? So the thing is, the moment O forms a bond with carbon, you notice that this O now has 3 bonds. So there will be a plus charge on the O. So same thing, the moment it has a plus charge, it is not favorable because it is electronegative. So how to remove the plus charge? To remove the plus charge, it undergoes heterolytic fission, whereby the H comes out as H plus. So now do you see the regeneration of catalyst? If you can understand this, then you'll be able to appreciate why the type of reaction is otherwise known as equivalence. Okay, then
Can you explain one more time?
which one?
I thought all cannot form true bonds. What's bigger?
But then the thing is, like for example, H3O plus, doesn't that mean that
Oh,
anything else? Can or not? Basically what I showed you on the whiteboard, the mechanism, is to help you appreciate why it is also known as improved sum. If now you cannot catch it, never mind, later on for carboxylic acid, we'll go through it again. Okay, for part 1, elimination, nothing new. For part 2, very important. Here, you draw like this, the O-level way. This one, I give it to you. But then for this, you draw the O-level way, I cannot give it to you. Why? Because the thing is, here you have a pair of geometrical isomers. Even though the question never says draw the geometrical isomers, by virtue of the fact that the question tells you 3 products are formed, tells you that hey, there is a presence of geometrical isomers, and therefore you must show it using the trigonal planar arrangement. And very important, you notice that here you cannot anyhow bond to your atoms. It must be carbon bond to carbon, C bond to C. This is a common mistake among some of you.
So you have to build it as CH3.
What do you mean by built-in? Like that? I don't want to see things like that, H3C. No. Because it is just a matter of how you position your atoms, your substituent. Yeah? Like that? Like that? No, not for me. Follow my way and you'll be fine.
Alright.
Okay.
Yeah? This part, although it seems very, very fundamental, but sad to say, you still cannot get the full marks. Why? Because number one, your presentation is horrendous. For the first row, you either talk about percentage by mass, if not, you talk about mass. There is no such thing as percent, percent what? 100% A, is it? Right? And if you write percentage by mass, there is no unit. If you write mass, I would expect to see the units over here. You understand? For the second row, very, very disappointing, very, very bad mistake. Quite a number of you just put MOL. The thing is, MOL is the unit. You cannot just put the unit alone. What is the header? So in this case, the header is either number of moles, LES, or amount, followed by the unit MOL. And here, the question type is calculate. When you see the word calculate, it means that workings must be shown. The same applies for the question type determine. Therefore, here I'm expecting to see some workings in the table. But quite a number of you just put the numbers of 1, 2, 3, 4. That's not correct. I need to see working. You understand? You understand the proper presentation? Okay? The next part also very. Do I need to go back? Do I need to go back? The next part very, very disappointing. A lot of you never see the word displayed formula. Let me tell you, displayed formula is a pet phrase of Cambridge. They like to ask it, especially in paper 2. So make sure you read the question carefully. And some of you very, very funny. You read that, okay, I need the displayed formula. Instead of showing the displayed formula in the equation itself, what happens is that some of you just use the condensed structural formula for the equation, and below the equation you draw out the full structural formula. That's like very silly, right? You're doing double work, right? Basically here what you need to do is just show the full structural formula in the equation itself. Okay? And when I say full structural formula, this is always a mistake made by students. They forget that there is an O single bond H. They just put OH. Wrong. Okay, so remember these are O single bond H. Last but not least, okay, these are the answer. I don't think it is that difficult. The reason why you cannot get an answer is you never read the question carefully. You never make reference to the previous part. That's why you cannot get the correct answer. Okay, people, I noticed another mistake. Here, when the question says write an equation, by default, you are supposed to write a balanced equation. What happens is that some of you gave the synthesis equation. What is the synthesis equation? You just show this, you put an arrow between them, you stop. Here, the question type is not a synthesis question, therefore it is incorrect. Okay, so remember, every time you see write an equation or write a balanced equation or construct an equation, by default it is a balanced equation, not synthesis equation. You understand? Hui Ming? Yes, good. Then, any question about the assignment? Any question about the assignment, people? Anything? Okay, come take out a piece of foolscap paper. Do I look like Mr. Ong? Mr. Ong likes to give like this, right? Oh, is it? Or like, in case you didn't realize, Mr. Ong also likes to give this kind of bite-sized exercise. Wow, you are very polite. You're welcome. Who wants to keep for Bella and Yedler? We'll keep for both, right? Okay, come 10 minutes, let's go. Class seems a bit deeper today. That's very strange. A lot of movement. time don't use purple color pen, exam only 2 of that, but now you can use because your MSc you actually use purple pen, right? You can remember for all exams, blue or black pen, no purple, no pink or whatsoever, especially for Cambridge, because I think they use a different color pen for the examiners to mark. Okay, come, let's go through the quiz. For the first question, really, I think this is the n number of times that we have done such a question, right? Correct? So please check and make sure your answer contains the underlined words. Don't have any of the underlined words means your answer is not complete. As simple as that. Is it difficult? No, right? We have seen it like for the third or fourth time already, right? In lecture notes, tutorial, question 13, assignment just now, and now the fourth time. Okay, question? No? Can I move on to the next question? Okay, so for the next question, you are given a reaction scheme, a synthetic pathway. This kind of question is very typical in A level. So what happens is that to form C, you are given 1 mole of OH minus aqueous. OH minus aqueous. And then when you look carefully at the reactant, you see CX bond. So what type of reaction is this? Riley? What type of reaction is this? You see CX bond, you see OH minus aqueous. What type of reaction is this? 5, 4, 3, 2, 1. Huh? You also don't know? Nucleophilic sub, right? If not, it is also known as hydrolysis, isn't it? Hans, you tell me you don't know? Okay, so the thing here is there is something special, and that is there is 1 mole of OH minus used. If you think that you cannot understand what on earth is happening here, let's go back to the fundamental. Here I have with me a simple Rx, a primary Rx. Okay, this is not a primary Rx, right? This is not a primary Rx. So what happens is that OH minus reacts with it to form this. This is a balanced equation. You notice that it is 1:1. Correct? So now let's say that the organic compound has 2 CX bond, like this. 2 CX bond. In order for all of them to be substituted, I will need 2 moles of OH minus. Make sense? So if you understood this, let's come back here. Here you see that you have 2 CX bond. So technically speaking, in order for both of them to be substituted, I need 2 moles of OH minus. But now, given the fact that I only have 1 mole, what happens? What happens? Brenda? Substitute the I1. Why? Exactly. So here, given the fact that you have limiting amount of nucleophile, in order for nucleophilic substitution to happen, it will target the bond which is weaker. And in this case, it is your CI bond. And then here, you notice that the idea about weaker bond is actually a follow-up from part A. So this is also an exam strategy. So let's say if you are doing part B, part C, part D in the middle, and then you find yourself stuck, you may want to look back at part A, see whether or not your answers in part A or the information in part A can help you answer the question in part B, part C. The same applies for looking forward. That means you can look at like part E, part F, part G. See whether or not do they give you any information. But very often it is the previous part that provides the clue. Okay? So now we know that it undergoes nucleophilic sub. So in C, we are going to obtain COH bond, right? Then we look at the second reagents and condition. Ammonia in ethanol. What kind of reaction do you expect? Ammonia in ethanol. Ammonia in ethanol, what do you expect? What type of reaction do you expect? Nucleus up. Nucleophilic substitution. Substitute one. So here in C, you know that you have COH bond, you have CCl bond. So which one do you substitute? Is it COH? No, is it COH? How do you know which one gets substituted? Is it CCl or no? Is it COH or is it CCl?
You see the final product.
Exactly. Here the question gives you the molecular formula of the final product. In the final product, do you see any Cl? No, right? So this tells you that it is the CCl that gets substituted. Let's say if the question never gives you the molecular formula of D, then how? How do you know which one undergoes nucleophilic up? No, not that. The answer to this is that in the chapter on alcohol, have you seen any reaction involving alcohol and ammonia? Don't have, right? Don't have means no reaction, no? So that's the clue. So this is the answer. Okay, from this question, I want to reiterate what I just said earlier on. OH minus is a poor leading group. So here you notice that there is no consulfuric acid to protonate the OH. Therefore, the OH is unaffected. And very important, you notice that here, the carbon is not bonded to carbon. So this is wrong. This is computer generated structure. But then the correct structure would be like this. Alternatively, you can draw like this. Why you can draw like this? Because it is already in skeletal structure. The next part, NaOH equals heat or heat under reflux, doesn't matter, straightforward. The next question, definitely nucleophilic substitution. I need to see the name there. How do I know that in this case it is SN2?
I'll not say SN2.
I will make it more specific, but if you never say, you will be penalized. Because it is a primary Rx, right? In case some of you don't know why is it a primary Rx, look at the carbon that is directly bonded to hydrogen. On the carbon, there are 1, 2 hydrogen and 1 big R group. So therefore, it is your primary Rx. So here, for the mechanism, right, I can draw like this, right? Okay. Okay, I draw like that, right? Can or not? Why? Why cannot? Exactly, because here you know that SN2, it focuses on inversion of configuration. The word configuration refers to the 3D arrangement of substituents. So to show the 3D orientation, you need your dash and ridge bonds together with your tetrahedral shape. Therefore, the answer is like this. Very, very important. Quite a number of you missed out on the negative sign. The negative sign needs to be there. And then the lone pair of electron is found on oxygen, not on hydrogen. So make sure your OH minus comes from the backside, backside attack. I think this part, Ruth, you got it wrong, right? That's not so. You must come directly opposite. And remember, in this case, the transition state will have a negative sign. Keeping square bracket, transition state. And then don't forget your leaving group, Br minus.
It will always be X minus unless you station.
But it will always be X minus unless you use ammonia or amine as the incoming nucleophile.
It's a H over.
Yes, that's right. Can? Okay? Yeah? How to draw mechanism for that one? Because that one, okay, Brenda is asking for the second question, right? You see that you have cyclohexane, then you have Cl or I, right? How to draw mechanism? It depends on whether it's in SN1 or SN2. This is a secondary Rx. So which one is it? So even if it is a SN2, same thing as before, you can use the dash and wedge bonds of the ring just to illustrate the 3D nature. So remember to show your carbon as well. Here I didn't really show the carbon. Still the same thing. Or do I need to draw it clearer? If you find it very funny, the ring, how come like that? Then you let this be the dash and wedge bonds or no choice. You understand? But then that will also mean that in the product, if let's say you let this be the wedge bond, then in the product you will also be wedge. Okay? If everything is okay, let's do a quick summary of what we have learned in alcohol lecture. You all learn anything from alcohol lecture? Okay, you may wish to turn to page 7 of your lecture notes. So alcohol, you know that like any other organic compound, it can undergo complete combustion. When it undergoes complete combustion, it forms carbon dioxide and water. The only thing about this part is your life would be so simple. Still remember in AMS, this is what you learn, right? So what the coefficient, stoichiometric coefficient? Ryan, Tom, what's the stoichiometric coefficient? Hans, how to balance the equation? Riley? Right. Simple, right? So here, with regards to combustion, it will be like this. So your challenge now is using this as the starting material, how are you going to balance the equation? You can see that in your tutorial question on e-learning, question 14, part 1. Okay, constructing a balance equation now using alcohol. Then, next, in O level, you learn about water reacting with metal, right? Correct? Water reacting with sodium metal. So now, instead of using water, instead of the H, I change it to R. The thing is, in O levels, water and sodium, what do you get? What do you get? NaOH, right? And swimming H2, hydrogen gas. So you see that this is where the reaction happens, right? Correct? Emma? Correct? Maybe I should draw it like this. So you see that this is where the reaction happens, right? So now, even though I change from H to R, this part is unaffected. Why? Because it doesn't participate directly in the reaction. It is this that participates directly, right? So by the idea of drawing parallel comparison, so here you are going to form Na plus RO minus. Of course, in organic chemistry, if you have an ionic compound, we write the N ion first, followed by an ion. This is in organic chemistry. Okay? Nonetheless, the hydrogen gas still reduces. Here, I want you to know two things. Number one, what is the type of reaction? Redox. Okay. Number two, for every 1 mole of OH, it produces half mole of H2. For every 1 mole of OH, it produces half mole of H2. So let's say in your compound, if there are 2 OH present, that means 1 mole of H2 will be produced. You understand? Okay. So next, I already said before, alcohol is a very weak acid, weaker than water. Therefore, you shouldn't expect it to have neutralization reaction with sodium hydroxide. So no reaction. And just now we have already seen esterification, right? Here, I want you to know that the reaction is incomplete. It is reversible. Reversible, we represent with this sign over here. And because it is reversible, it means that at any point in time, I have my reactants present. Therefore, the U of the ester is going to be low. Okay? Not, okay, like what happens to be her surname, low, right? So now the thing is, if I want to increase the U of the ester, how come you never laugh? Okay, good. So, in order to increase the U of the ester, you have to make the reaction complete. So therefore, to make the reaction complete, you got to use a more reactive reagent. And that comes in the form of acid chloride. So this is the structure of acid chloride. Why is acid chloride more reactive than carboxylic acid? Because our friend here can leave easily as Cl-. It's a good leaving group. You understand?
How come the note say right?
Okay.
How come both form ester? But then one is esterification and one is desalation.
Okay, esterification, acylation, these are just the name of example. But then the type of reaction, both can be called condensation, both can also be called nucleophilic substitution. Okay? Can. So therefore, for this part of these examples, I classify them under the breaking of OH bonds. Can. So any question about any of the examples here? So same thing as before, make sure you remember the reagents and conditions carefully, exactly. Cannot take shortcut one. Then, so with that, I'm going to stop here because the bell has rung. Thursday, when I come back, I'm going to do summary. I want you to prepare the following question. 8, 5, 6, 7, followed by all the what? 11, 12, 13. So I want to do this one first. Question 8. And these are your MCQ. Oh, I think there's also a distinguishing test. Question 9. For alcohol. Yeah.
Isn't it just like saying 5 all the way?
Assignment due on Friday before Chinese New Year. Yes, Riley, what do you say?
5 all the way down to 13 without 10.
Okay, sure then. Okay, I want to do 8 first because 8 I think once I go through a summary it becomes easy. So today you are supposed to hand in to me your RX. You have practice, right? It's like that. Alex, year 2 is like that. When we go into term 2, term 3, even more work, not just from chem but other subjects as well. Don't forget, we still got to practice past year paper. Right? Then, so tomorrow e-learning, any problem we talk on Ask and Learn forum. Yes, just the RX only. Yes. And you all pass it to Ryan to put inside my vision.
I think there's one page I never completed.
There's one page too. Never mind, after lesson, carry on. Rugby starts at 6, right? Or 5:30. Okay, I will talk to Mr. Cha to give you extension. Right, Mr. Cha is on duty, right? Mr. Dennis Cha. Yeah, Riley. You must be a good role model to your teammate.
Guys.
Right?
Guys, yeah, any of you pass me this paper? Ew, I forgot to off the recording.
Right?
Right, no.
Yeah, teacher got pin.
Which page? 11 do together with Riley lah. Then you all can discuss.